Take a look at this graph. Now, this is quite a new graph if you don't know what it is, and graphing it would be tricky. Finding its equation would be quite tricky. So, very not, because there can be an easy way to do this. Welcome to my channel. Today we're looking at exponentials. That graph was an exponential, and today we're just looking at what exponentials are and what are the ways we can represent them. How can we write their equation? So, here's a visual graph of how an exponential looks like. So, as you can see, it kind of shows kind of like growth going towards the right side. Now we can manipulate this, we can turn it upside down, we can do a number of things to it, and that is what we're going to be exploring today. So here's the general form of exponentials. Y is equal to k to the power of x minus a plus b. Now over here, b is a new thing because we haven't seen something called an asymptote before. Asymptote is basically a point which kind of like a line which the graph is approaching but can never meet. In the picture, you can see there is a line and the graph is never going to go beyond that line. And the value, that is basically y is equal to 1 in this example, and basically this graph is never going to go beyond y is equal to 1. It's never even going to touch that point. So that is the vertical asymptote. We've also got the horizontal shift, and we've got our stretch factor, which is our k. Our a was our horizontal shift. So now let's see how this really looks like on Desmos. The general formula for exponentials. And now let's see what happens when we change each variable. Now notice, as k is decreasing, the graph is stretching out more. The graph is stretching out more, and as soon as we go below 1, the graph flips around. And it's basically, it happens very quickly. And this way, the graph keeps, as k increases, the graph is going to get more and more kind of angular. This angle over here approaches closer and closer to 90, and as we stretch it out, it becomes less of that high angle, and once we go into our decimals, positive decimals, it flips around. Now notice, as soon as I go to 0, there is just a line going this way, and when we go into the negatives, it disappears. Why does this happen? Well, as long as we have a negative whole power, this will be fine. K to the power of something, k to the power of negative something is going to be fine. Negative k to the power of something negative is going to be fine. Something positive even. But as soon as we go into our decimal numbers, a negative number raised to a fraction is kind of like the square root, or the cube root, something like that. That's not going to work for negative numbers because then we go into our imaginary numbers realm. So I'm not really going to expand on that too much because it's quite complex, because those numbers are complex numbers. But basically what happens is that there is basically, Desmos doesn't show, but there is basically a bunch of dots at all the whole numbers, at all the points where there are whole numbers, but there are no dots where there are fractional numbers, because that is where the number becomes imaginary. Now, moving on to a. What happens when we move a? As you can see, a is responsible for our up and our kind of like, let me kind of squish it a little bit, and now we can see the effect of a more properly. What is happening is that our graph is moving horizontally, but our asymptote, which is b, is 1. So the graph is approaching y is equal to 1, but never quite meeting it. So you can see the value gets closer and closer to 1, but it will never go exactly to 1. And our a, let's say our a is 5. Basically, to find our a, what we're going to do is, we know our asymptote is at 1, and we're going to go up 1 unit to 2, and the x value at 2, which is right here, which is 5, is our a value. So it's basically, and notice this point, the 5, 2 point, stays the same. It is the graph may move around, the k value may change, but the a value stays the same. The graph passes through 5, 2, no matter what. So that is what these do. Now, as I said, we can make k into a decimal number to flip this around. However, what we can also do is, if we did 1 over k, what is really happening over here is the graph is flipped around, as you can see. And once we go into our decimal, it flips to this way. You can see these are basically mirrors of each other. Now, why does this happen? Now, this graph flips around and is a mirror of this because what's really happening is that our k is now being raised to a negative power. Because imagine this is the same as writing this, but we add our a because our power becomes negative, so we need to multiply everything by -1, and that's why this flips around. So we're raising it to a negative power now, and that means that there is going to be decay. So as our x increases, our y is going to decrease, and that becomes the reason for, so this is the decay one, and we can see as our x increases, our y decreases. So that's decay, and this is growth. So that is how our exponential graph looks like. Now let's try and generalize exponentials. So here we've been given a graph, which is y is equal to 2 to the power of x minus 5 plus 4, and the domain is that x is greater than or equal to 0 and x is less than or equal to 5. And we can see that we just want to translate this shape, which is move this shape around. So using our knowledge of a and b, which is a part of the general formula, we're going to try and move this graph around. Over here, what we can do straight away is I'm just going to copy this and paste this. So now we've got our new one that we're going to modify. So over here, since we want to move it horizontally and we want to move it vertically, I'm going to use the variables h and v. Ignore this line because there's the answer, but let's see how we can get to it. So what we can do is now we want to have like a horizontal shift of something. And remember, we had in our general formula something like k to the power of x minus h. So it was always x minus h, which is why we're going to go ahead and say minus h so that we can move it around. Then what we're going to do is also add our vertical shift to this. So what we're going to do is in our general formula, we were given plus b. It was always adding on the vertical shift. So this is why we're going to add on our vertical shift over here. So now we just need to figure out our domain. So what we really wanted for the black one is that we want the shape to look like this, and we want to move it around. So the width of the shape is actually, as you can see, it ends around 5 and it starts at 0. So the width of the shape is 5. So we want the gap to always be 5. So if we went ahead and added our h on both sides, what's going to happen is that there is always going to be the difference of 5 between these, but we're going to use our horizontal shift to locate our graph. So we can see that this can move around and we can move this up and down as well. So this is how we can use our formula in order to translate graphs, our exponential graphs. So I hope that made sense. Now let's look at how we can scale this graph we started with, and I've just put it over here. Sorry, this was supposed to be 5, so now we can see this better. So this is how we started off, and now we want to scale it up. So there's this option that we can do. Here I've written 1 over k because I want to raise it to a lower power. This means that the graph is going to be expanding more horizontally rather than vertically. So let's look at what happens now. So this has also got some of its translation, so I haven't removed what we did earlier, but I've just added on our k. So, and I've also multiplied this domain by k so that we can make it grow bigger, so that we're covering more of its width, so its width is expanding as well. So we can see it over here. and you can see how it's kind of expanding outwards, right? And we can also scale it vertically, using this. Over here, I've written k as a coefficient of this thing over here, which is 2 to the power of this. And now when we change k over here, look at how it's just expanding upwards. This is because I haven't changed the domain, so I could do this again, but let's see how that actually looks like, just to be sure. Now, as you can see, this looks way too big. This is looking way too big. And because as it's expanding more vertically, it is squishing as well a little bit, which means this, as we increase our domain, it's going to look quite crazy, which is why I left it as h plus 5, because now we can see it expanding upwards. So I really hope this made sense to you guys. This is how we can scale it up and down. We can even flip it over, which is quite cool in my opinion. And you can see that it's also moving a bit down because we've got our asymptote, which is making it go up and down. But yes, this is how we can scale our exponential graphs. Thank you so much for watching this video.